What is good on, guys, and welcome back to another one of the videos. So it's about 1 hour after I did the first one, and I just thought let's do another one because I usually like to do 2 videos back to back. So anyways, that's just an aside note, but actually the reason that I'm doing this is because while I was talking to my mom, she asked me what video I was doing. I told her that it was functions, and she asked sine, cosine functions. I said no. But actually, that's a very good point. I should do that. So let's have a look today at sine, cosine, and tangent. But unlike the video that I have already done explaining these functions, I have not really explained these functions. So the funny thing is that while I did talk about these 3 functions in the unit circle, I never talked about what it actually means. So today we're going to be having a look at what this actually means. And yeah, let's start off with our xy, but instead of naming this x, we're going to name this phi, right? Phi. Now you might ask, okay, what is phi? Well, phi is measured in radians, right? And so phi is actually just the measurement of degrees, right? So you have, what is a radian? We have degrees and we have radians, right? So 1 rad, rad, is equal to 2 pi, right? So 1 rad is 2 pi, and 2 pi, excuse me, 2 pi is what we call a full circle, right? So when I stand in this, putting in this position, I turn around once around my axis, and I face that, and I'm looking the same way again, right? That's 2 pi. That's a full revolution, right? So good. So now let's maybe draw this here, and actually we're gonna draw exactly what we drew before, which is our nice little friend, the unit circle, right? So this is our unit circle right here, and keep in mind that these two should be on the same height, right? So let's just think what I actually drew here. So we have one circle, and for the guys that actually know, the radius is 1, right? The radius is 1, because so we give this as a unit circle. So let me just actually write that there also. Unit circle here, and we have a diagram here, right? So we have the angle and just some value, y value, you know? Good. And now what we do is first we actually say 1 is here, right? Because that makes sense, because the radius is 1, so 1 is here. And now we can actually say, okay, we have pi over 2, and then in the same distance we have pi again, and then the same we have 3 pi over 2, and then we have 2 pi, right? Good. Now, so let's understand this first. So pi halves means 90 degrees, right angle. Pi, 180 degrees, and so on and so forth. 90, 180, 270, 360, right? And then we start from the beginning, because basically whenever you calculate an angle, right? So I could also say then that I have that this angle, let's say that this is 45 degrees, right? Let's just say that this is 45 degrees. Now I can say that from this line right here, which is our 0 line, or our point of our line of reference, right? I can say that this angle is minus 45 degrees, because remember, in maths we're always going against the clock, right? Against the clock, which is the positive direction, this is the negative direction. So I can say this is minus 45 degrees, right? From our line of reference, or I can say that this is 315 degrees, right? But I can also say that this is 315 degrees plus 360 degrees. Because, what does that mean? I go 360 and then 315, right? You guys have to understand that it does not make a difference whether or not I add 2 pi again, because it just starts from the beginning again. So actually we have pi half, pi, 3 pi over 2, 2 pi, and then the whole thing just starts over again, starts over again, starts over again. Now the question is, what starts over again? What is this all about? Well, let's actually have a look. This is important to understand because this is actually what sine, cosine, and tangent are even, right? So let's have a look. So I'm just gonna draw a random line, okay? So for this line, right? This line right here. Now, for the guys of you that can remember, we have the sine here. We have the cosine, which is just this length, right? So let me actually take the green color for that. And we have the tangent is here, right? So let's just do this. There we go. And we have the tangent, which is this length, right? Let me just extend this. The tangent is this length. Tangent, right? Good, great. So if we now take the radius, which is this, right? This line from here to here is the radius, right? And this radius does a full 360-degree or 2 pi rotation. What does that mean for us? Well, it means that actually we can take these values, plot them into a diagram, and we actually get sine, cosine, and tangent. Not the functions in trigonometry, but the actual functions, sine, cosine, and tangent. So, and we can actually even put this in a different way. I'm just going to put this here. Sine of an angle is sorry about that. Y of an angle is sine y, right? Good. So this is actually the way that we write this. So, anyways, let's now put this into a graph, right? So, if you guys can remember, maybe we have some starting values, some extreme values, and then some values which are just in between. So maybe you can remember. Let's just put some values here. Sine of 0, right? My pen is terrible. Sine of 0. What is that? What's the value for that? That's of course 0, right? Good. Sine of 90 degrees. Let's see. Sine of pi over 2 is 1, right? And so on and so forth, and we get is equal to 0 if we continue with this pattern, and is equal to -1, right? So in this diagram, we already know where the sine has to have which values at which points, right? So we just put this in. So we have sine is red in this circle right here. So we just do the same as we did before, right? We know the point. We know that sine of 0 is 0. So we just have 0, 0 starts in P 0, 0, right? So easy. Sine of pi divided by 2 is 1. Okay, so pi over 2, and we know that the radius of the circle is 1. So simple, right? Let me just make some lines here to help myself. All right, it's 1, right? Simple. Pi halves, 1. Easy. Now, we continue. Sine of pi, 0, right? So, pi 0, all right, good, I know that. And then -1. Okay, so we're here. And then, of course, I said 360 degrees. 0 is in this case the same as 2 pi. So we are at 2 pi. So we are at 0 again, excuse me. So, okay, now, okay, does it look like this? No, it doesn't. So that's why I didn't draw that like that straight away. So no, it does not look like that actually. What does it look like? First, let's have a look at cosine. Cosine of pi over 2 is 0, right? Let's start with cosine of 0 though, which is 1. Let's continue with cosine 3 pi over 2, which is here. So let's actually remember we have cosine of 0 is 1, cosine of pi over 2 is 0, and then we just have pi and then 3 pi over 2. So we have this is equal to 0, and then we have cosine of pi, which is just the cosine of 180 degrees, which is -1, right? Good. So what are we actually seeing? Well, let's not get ahead of ourselves. Let's actually put this in here. So cosine of 0 is 1, okay. Point here. Cosine of pi over 2 is 0, okay, that's interesting. Cosine of 3 pi over 2 is 0, okay. And cosine of pi is -1. Alright, well. And we have to return our, let's do this slowly. So we know that the value of 2 pi has to be the same as the value of 0, right? So we have to end up here again. 0, 2 pi, same thing. Good. Tangent is a little bit more difficult, so I will not cover the tangent function, although it is not that difficult, but I'll leave it out for this one. Okay, let's just talk about sine and cosine here because I think it's more convenient. Good. So we have these values and these values. We put them in there. Now we have 4 points or 5 points each, right? How does this help us? How can we draw this function? Well, one thing to do, of course, would be to take some values in between. So you could say, we know that the cosine of 30 degrees, how much is 30 degrees in radians? We can figure that out, but we know that the cosine of 30 degrees, sorry, sine of 30 degrees is 0.5, right? Shit. Sorry about that. Sine of 30 degrees is 0.5. Good. How can we work out 30 degrees in radians without making it too difficult? So, cosine of pi over 2 is 0. Sorry about that. Let's start. Let's just make this really simple. Pi over 2 is 90 degrees. And oh, we have 30 degrees. What if we just go divided by 3 on both sides? Easy. Pi over 6 is equal to 30 degrees. So we just write sine of pi over 6 is the same as 0.5, right? And cosine of 60 degrees is 0.5 as well. So we just do the same thing again. We say pi over 2 is 90 degrees. And we need to divide this by what? Or multiply this by what? Now actually I would do this a little bit differently. Let's get rid of this. Let's say pi is 180 degrees. 60 degrees, 180 degrees, just divided by 3. And there we go. Pi over 3 is 60 degrees, right? So we can say pi over 3 is, sorry about that, cosine of pi over 3 is of course 0.5. Guys, remember, sine, cosine from -1 to 1. There cannot be sine or cosine values that are higher than 1 and lower than -1. Good. So, and now we have all of these values. Now let's actually put these values into this diagram right here. Make sure we do that. So we have pi over 2 is here, which is 60 degrees. So we can actually split this into 3 equally large pieces about, right? Just put it in. So we have pi over 3 is 0.5. So we have 0.5 is around right here and right here. So pi over 3, 60 degrees, 0.5, put the point there. Great. Pi over 6, 0.5, put the point here. Oh, sorry about that. That's the wrong color. There we go. And you guys can see that a pattern is starting to emerge. Now it still kind of looks like it's just straight lines connecting these. But what it actually looks like, now I'm going to actually draw the solution here, or I'm going to try to draw it, is this. Alright, so I tried. I hope you guys can see that actually is what we call a wave function, right? Because it looks like waves, right? Cosine, sine are just waves. Now, why is it like this? So this is actually what actually a cosine and sine function look like, right? And let me actually write that this is a sine function and this is a cosine function, right? But remember, this is just the standard function, guys. There is actually 3 different types with which we can alter this function, which I think I will cover in this video. But anyways, remember, the sine and cosine function, they look like this, right? They go up, have a high point, and then they go down, right? And they go up, they go down. Alright, so a standard cosine and sine function are both 2 pi long. What does that mean? They start and end at 2 pi. How can we prove this? Well, look. At this point, it starts to go up, and then it goes back down, right? And at this point, again, it starts to go up, and then it goes back down. So this is basically the interval at which it completed a whole circle, at which this radius has revolved around this circle one whole time, 2 pi times, right? Same with cosine, except for the fact that cosine of 0, as we know, is 1, right? So I should maybe write this a little bit better, but let's just leave it like this. Cosine of 0 is 1. This is why we start here. And the really smart people of you are now going to be thinking, well, okay, sine, cosine, don't they look similar? And that is a perfect point to make, because they are actually the same, except for cosine starts later or earlier, whatever you want to, however you want to see it, right? Because if I actually go back, same function, right? Or here, if you take this compared to this, it's the same, right? So they are actually the same function, but the sine starts the sine starts later, right? In this cosine started here. All right, it really depends on how you define it. But what I want you guys to understand is that sine and cosine are actually the same function. Only the starting point is different, right? Cosine starts at 1, sine starts at 0. But other than that, the function has the same, well, it looks the same, right? It's just plus, and so we can say one thing, right? What can we actually say, maybe, to put this a little bit into a mathematical perspective, right? So we can say y of phi is equal to sine of phi, and maybe let's put it a little bit differently. We can say, except for y of phi, let's just get this out of here, and let's just say is equal to cosine of phi. Is this a true mathematical expression? No, except for at these points, 2 and 3. 2 points in all of these things, but that's not the question, right? This is actually incorrect, right? What do we have to write here to make this equal? I'll actually let you guys think about this, and maybe answer it at the end of the video. Maybe I won't. But again, think. Sine is just the cosine, but it starts so many degrees later. Anyways, good. Let me just leave this as an open question. So, let me summarize this again for you guys. we have the unit circle, which is here. Radius is equal to 1, right? So we just took the top and the bottom of the circle, extended it, as we did with the middle line of the circle, right? We have the x-axis is phi, which is measured in radians, and 1 radians is equal to 2 phi. Great, we got that. And then we said, okay, let's try out some values. We know that pi over 2 is 0, and so on and so forth. Then we did the same with the sine, right? And so on and so forth. And we said, okay, when the radius has done a complete revolution, just start at 0 again. So what we can actually do is this point must equal this point, must equal 4 pi, must equal 6 pi, must equal 8 pi, must equal 10 pi, and so on and so forth. Same with cosine. Cosine of 0 is 1, cosine of 2 pi is 1, cosine of 4 pi is 1, cosine of 6 pi is 1, right? Easy, good. And then we just said, okay, kind of looks like that I drew this. I mean, this is the function that you get for plugging in all the values, right? This is just the basic way that you draw these functions, right? But I know already how it looks, so I just drew it for you guys. Yeah, and then I said that they look similar, which they obviously do. I mean, they are just, you could say that they are the same, but they're not exactly the same because they start at different points, right? Good. So yeah, guys, this was just a quick video, but I wanted to showcase sine, cosine, and tangent, and for you guys to, yeah, maybe visualize it a little bit better. And actually, because this being such a short video, let's actually do some more and actually have a look at the ways that of which this function can be altered, right? So usually these functions are useful in, of course, trigonometry and functions where you only need the base function, right? Sine or y of x is equal to sine of x, right? But this is not the case in most applications, right? So let's actually have a look. What can we do? So the basic, I'm just going to write this in y of x, right? I'm not going to write y of phi anymore because I think it's just a little bit more, it's a little bit more, like we have always done it like this, and so I think you guys understand this better if I just write it y of x, right? So what do you guys think we can do, right? Well, what can we do with the circle? I said in the triangle, in the video of the triangle, that this circle, or when you're multiplying by cosine or sine, that just means that this side is getting bigger. And so when a side gets bigger, so for example, sine is like 5, which is impossible, of course, but you can multiply some sine value to equal 5, right? So we can basically just say, okay, instead of the circle being 1, why isn't the circle 5? Or why isn't the circle 10? So actually what we can do, and okay, and another question, how do we do it that this maximum value is 10? What do we have to do with the basic function sine of x to make this most outer point on the function 10? Well, we can add 10, right? We can even add 9. But if we write plus 9, doesn't that mean that every value goes up 9? It does, so that's the problem, right? So what we actually have to do, maybe you guys figured this out, is 10 times sine of x. Because now we stretched the whole function, and this point on the top is now 10, right? And of course this is 5, right? Sine of or in this case, if you plug in pi over 6, which is 30 degrees, you get, of course, 5, right? Yeah, exactly. So you have 10 times sine of x if you want to have the highest and the lowest point at 10, right? what else can we do? So we said we can add and subtract. Absolutely we can. What does that do though? If you write plus 2, what does that mean? It means that everything that we plug into this variable is 2 is added. And what does that in conclusion mean? Well, it actually means that this center line on which we have based these functions shifts up 2. It's not that difficult. It really is easy, right? So this function just means that the whole function shifts up plus 2. And there is no, I want to say a bad word, but and there is no side effect like in the quadratic thing. This plus 2 actually means that it shifted plus 2 in the y or in the y direction up or in the y direction down, right? This actually is what this means. Great. And we have one more thing that we can do. We can change what is in the brackets. Well, okay, how do we do that? Let's say y of x is 10 times sine of 2x plus 2. What? What has he just done? What does this even mean? Well, 2 times x, what does this mean? That means this function is completing this one wave, but 2 times in the same period. So from 0 to 2 pi, you do not have one of these waves, but 2 of these waves. Right? So maybe we can sketch this, right? Let's maybe put it in here. So if it completes 2, then this whole thing basically shrinks by half. So we have to go up here, like that, go down, go up, go down, go up, down, up. This, if this most outer point were 10, and the center line were at 2, then this would be this function, right? So let's maybe actually draw, to not confuse you guys, a function of this, right? So let's do that. So we have y here, we have x here, we have 0 here. So we just say that 2 is here, we say that 12 is here, and we say that negative 8 is here. Keep in mind, guys, we don't go from 10 to 10 or from negative 10 to 10 because that would not make sense, because we're going 10 up and 10 down. So 2 minus 10 is negative 8, 2 plus 10 is 12, right? And now we just do the same thing. We do this. We have pi over 2. Just thinking of a better or a faster way to sketch this, but 3 pi over 2 and 2 pi. Great. And now we can actually do it. So let's do it. So we have this. Yeah, looks bad, but I think you guys get the point, right? So 2 pi is right here, and pi is right here, right? 3 pi over 2 is right here, and 2 pi is right here, right? So yeah, good. I'll put this away maybe. Good. And one more thing that we can do, guys, is this video is actually getting kind of long again, but in the brackets, which is also as the solution for this right here, this right here, in the brackets, we could also change something else. Why? God, why do these freaking pens not right? Y of x is 10 times sine of 2x plus pi plus 2. 10 times sine of 2x plus pi, what does that mean? Well, if we add pi, we're shifting the function, right? Because we're adding a value. So what does it mean? If I have cosine and I add pi to the function, then I shift the function. I gotta think about this myself. To the left, right? So if I have the cosine function and I have plus pi cosine of an angle plus phi, then I shift it to the left, right? So plus phi would be, or I shifted phi to the left, right? So maybe to solve this question, sine of plus pi is equal to cosine of phi. Does that make sense? Because again, we said we shift to the left, right? So of any angle plus pi, which is just sorry about that. That is completely wrong. I didn't mean 180 degrees, but I meant 90 degrees, of course. So 90 degree shift to the left, pop, and we are exactly equal. So this is actually a true condition. This is not true. This was just the setting. Right? Camera just turned off there. Anyways, one last thing for you guys. How do we actually call these variables? I'll do this really quickly because I think my storage is full again on the camera. So how do we call these variables? Well, we have, remember this for the next video. This is the standard form for cosine and sine. We have a times sine of omega times t plus phi plus right? Doesn't matter. So we have A stands for amplitude, which is the line that this function meets exactly once per the wave. And then we have omega, which is a Greek letter, which consists of 2 pi times f. Frequency, right? Frequency, we have frequency means revolutions per revolutions per second. 1 revolution per second times 2 pi, we get this exact thing. Great. And then we have plus phi. This is the in Deutsch we call it Phasenverschiebung. So this is basically how far to the left and right we push this thing. And then B is the center line of the function, which is rather on top or on the bottom. Now you can write a plus or a minus here. That doesn't matter really. Keep in mind that if it's plus, function is to the left. If it's minus, function is to the right. Guys, I appreciate you for watching. And yeah, I hope this was a good video again. And wish you all a wonderful day. And have a great week. And thank you. Goodbye.